Uh, Good morning, everyone. Today, we are going to discuss hypothesis testing for intelligent inference. This topic is very important because it helps researchers, business, and intelligence system make decisions based on facts and data rather than guesses or assumptions. Hypothesis testing is commonly used in many fields such as education, healthcare, business, engineering, and artificial intelligence. It allows people to determine if there is enough evidence to support a claim or if the results only happen by the chance. In this discussion, we will learn about the basic concept of hypothesis testing, the different types of tests, common errors, advanced techniques, and how hypothesis testing is applied in intelligent systems such as machine learning, fraud detection, and A/B testing. By the end of discussion, we will better understand how hypothesis testing helps people make more accurate, reliable, and evidence-based decisions. First is introduction to hypothesis testing. Hypothesis testing is a statistical method used to make a decision based on data. The researchers use to determine whether there is enough evidence to support a certain claim or assumption. It is very important in science, business, and healthcare engineering, and artificial intelligence because it helps people avoid making decisions based on only on guesses or opinions. Instead, the decisions are made through careful analysis or of collected data. In many situations, people need to know if a certain action really creates a chance. For example, uh, schools want to know if a new teaching strategy improves grades, or a company may want to know uh, if a new advertisements increase in sales. With hypothesis testing, helps answer this question by using evidence and statistical methods. And then another example is a school wants to know if a new teaching method improves a students' grades. They compare the grades of students before and after using a new method. Next is core concept and definitions. Hypothesis is a state or assumption about population or a process. In hypothesis testing, there are usually two hypotheses, the null and the alternative. First is the null hypothesis. It states that are no effect or no difference or no relationship between variables. The alternative hypothesis states they are relationship, affect, difference. The main goal is to test whether the evidence is strong enough to reject the null hypothesis. These concepts are very important because they guide the entire research. Because without clear hypothesis, researchers will not know that we are trying to improve or disprove. Hypotheses help make studies more organized and focused. Example, a researcher may assume that drinking coffee does not affect concentration. The null hypothesis that alternative hypothesis is that coffee does not concentration. Next is historical development. Uh, Hypothesis this thing become popular in early 90s, become of statisticians such as Ronald Fisher and Jerzy Neyman. Fisher introduced ideas like significance studies or testings and p-values, while Neyman and Person developed decision-making methods using error states. Over time, new methods such as Bayesian and statistics and bootstrapping were introduced. These methods make hypothesis testing more flexible and useful for complex data and modern intelligence systems. Today, hypothesis testing is used in many fields including medicine, education, economics, technology, and machine learning. The development of computers has also made it easier to perform complicated statistical tests in short amount of time. Example, early scientists used hypothesis testing is to study farming methods, medicine, population growth. Today, it also in AI, machine learning. Fundamental hypothesis testing methods. The first step in hypothesis testing is to identify the research question. After that, the null and alternative are written. Then the data is collected and a statistical test selected. The test result is compared with the chosen significance level, usually 0.05. Ang conclusion is made about whether the null hypothesis or should be rejected or not. This process is very important because it provides a clear organized way to study a problem. Instead of depending on personal opinion, researchers use a step-by-step process to reach a conclusion. This makes the result more reliable and easier for other people to understand. Researchers must be also careful in selecting the correct statistical test. Different tests are used depending on the data, the number of groups being compared, and the purpose of the study. Example, a company tests whether a new phone battery lasts longer than the old battery by collecting data and comparing the result. Next is the null and alternative. The null is often written as HO, while the alternative is written as H1 or HA. For example, if a company wants to know whether a new product design increase the sales, the null will state that there is no increased sales, while alternative is uh, the new design product is increased sales. The alternative can be one-tailed or two-tailed depending on the direction of the expected effect. The null hypothesis is usually testing or the starting assumption because it assumes that nothing has changed. Researchers has only reject if there is enough evidence from the data. This helps prevent people from making conclusions too quickly without enough proof. Wanted hypotheses are used when the researchers expect a chance or changes in only one direction, such as increase in cells. Total hypotheses are used when researchers only want to know if there is any difference, whether it is increase or decrease. Example, uh, HO, students who study with the music and students who study without music have the same test scores. H1, studies who study with music have different test score. Next is test statistics and p-values. The statistic is a number calculated from sample data. It shows how far the sample result in the from what is expected under the null hypothesis. The v-value is the probability of obtaining the observed result. If the null hypothesis is true, a small p-value means that the observed result is unlikely under the null hypothesis, so that the null hypothesis may be rejected in most studies. If the p-value is less than 0.05, the result is considered statistically significant. Test statistics are important because they summarize the information from the data into one value. Common example of test statistics include the z-scores, t-score, and f-value. Each statistical test uses a different formula depending on the purpose of the study. The p-value helps researchers know whether the results are strong enough to support the alternative hypothesis. A high, a high p-value means that the result may have happened by a chance. while the low p-value means the result is less likely to be random. Example, if the medicine trial gives a p-value if 0.03, it means there is only 3% chance that the result happen randomly if the medicine has no real effect. Decision rules and error types. There are two common types of errors in hypothesis testing. A type 1 error happens when the null hypothesis is rejected, even though it is actually true. This is called false positive. A type 2 error happens when the null hypothesis is not rejected, even though it is false. This is called a false negative. Researchers try to reduce both types of errors because they can lead to an incorrect conclusion. Decision rules are used to guide researchers on whether or reject or accept the null hypothesis, usually if the p-value is lower than the significance level. The null hypothesis is rejected if the p-value is greater than the significance level. The null hypothesis is not rejected. Understanding these errors is very important because wrong decision can have serious effects. In medicine, false positive may lead unnecessary treatment, while a false negative may prevent sick person from receiving proper care. Example, a type 1 error happens if the doctor says patient has a disease when they do not or do not have. A type 2 error happens if the doctor says a patient healthy when they are actually sick. Next is power of test. The power of test refers to the ability of a statistical test and correctly reject false null hypothesis. A powerful test is more likely to detect a real effect if exists. Power is affected by sample size, significance level, and the size of the effect being measured. Larger sample size usually increase the power of test. Example, a test with a larger number of participants is most or more likely correctly. It detect whether a new product really improves sales. Next is parametric test or parametric test. Parametric test is a statistical test that are required certain assumption about the data. The common assumption is that the data follows a normal distribution. Another assumption is that a variance of the groups being compared similar. Example of parametric tests include t-test, ANOVA, and linear regression. These tests are widely used because they are powerful and efficient when the assumptions are made. Parametric tests are commonly used in research because they can provide more accurate results when the data fits the assumption. The t-test is used when the comparing the average of two groups such as test scores of male and female students. ANOVA is used when comparing three or more groups, while linear regression is used to study the relationship between variables. Researchers should be first check whether their data is normally distributed because using parametric test. If the assumptions are not met, the results may become unreliable. Example, a test may be used to compare the average height of boys and girls in class. Next is non-parametric test. Non-parametric tests are used when the assumptions of parametric tests are not satisfied, when the tests are useful for small sample size. Ordinal data or data that is not normally distributed. Example, include the Mann-Whitney U test, Kruskal-Wallis test, and Wilcoxon sign rank test. Although they are usually less powerful than parametric tests, they are more flexible and reliable and for unusual data. These tests are called distribution free tests because do not require the data to follow a specific pattern such as normal distribution. Non-parametric tests are often used in survey, ranking system, uh, and situation where the data contains extreme values or outliers. Even though they have lower statistical power, non-parametric tests are still very useful because they allow researchers to analyze data that cannot be studied using parametric methods. Example, a man Whitney U test may be used to compare customer satisfaction because the ratings are based on logs. Advanced techniques in hypothesis testing. As the data becomes more complex, more advanced methods are needed. Researchers often test several hypotheses at the same time, which increase the risk of making errors. Advanced techniques are used to manage which or these risks and improve the accuracy of the result. Example, a researcher studying many health factors at once may use advanced methods to avoid incorrect conclusion. Next is multiple comparison problem. This when the tests are performed at once, the chance of finding false positive result becomes higher. This is known as the multiple comparison problem. To reduce this problem, researchers use correction methods such as modificationary correction. These methods lowers the significance level for each test so that the overall error rate remains controlled. Example, uh, a researcher tests 20 different medicines. At the same time, there is a higher chance of getting at least one false positive result. Next is Bayesian hypothesis testing. Bayesian is hypothesis testing is different from traditional frequent test testing because it includes prior knowledge or previous information. Instead of focusing only on the same data, Bayesian methods combine prior beliefs with new evidence. This approach is very useful in intelligent systems because it can update conclusions continuously as new information becomes available. Bayesian testing is widely used in artificial intelligence, machine testing, uh, machine learning, and prediction system because it allows decision to improve over time. For example, a recommendation system can adjust its suggestion based on the user previous choices, unlike traditional methods that only focus on rejecting or not rejecting the null hypothesis. Bayesian methods provide directly probabilities for how likely a hypothesis is true. Another example, a weather forecast system may use previous weather patterns together with a new weather data to predict if it will rain. Next is key concept in Bayesian testing. One important idea in Bayesian testing is the Bayes factors, which measures the straight evidence for one hypothesis compared to another. Another important idea is the posterior probability, which is the updated probability of the hypothesis. After considering new data, these ideas are especially useful in artificial intelligence, where the data need to learn and adapt over time. Example, if the data shows that disease is spreading faster than expected, the posterior probability of an outbreak becomes higher. Next is application in intelligent inference system. Hypothesis testing is widely used in intelligent system, and the machine learning it helps determine whether pattern relationships or changes in data are meaningful. In intelligent system, it is important to make decisions based on reliable evidence rather than random variation. Intelligent inference system use data to predict outcomes, identify pattern, and solve problem. Hypothesis testing support this system by checking whether the results are statistically valid. This is very important because machine learning models may sometimes find patterns that are only caused by a chance. By using hypothesis testing, intelligent systems become more accurate, trustworthy, and useful in real-life situations. Example, a smart traffic system may use hypothesis testing to determine if changing traffic light timing reduce traffic jam. Next is designing A/B test. A/B testing is a method used to compare two versions of the product, design, or strategy. For example, a company may compare two website design to see which one attracts more customers. Hypothesis testing is most or used to determine whether the difference within the two versions is statistically significant. This method is common in a business, marketing, and technology. Example, an online store may test whether a red button or blue button gets more customer clicks. Next is fraud detection and anomaly detection. Hypothesis testing is useful in predicting or detecting fraud and unusual behavior. For example, if a bank notices the customer suddenly makes very large purchases, hypothesis testing can help determine whether the activity is normal or suspicious. It can also use cybersecurity, healthcare, financial system to detect unusual events. Fraud detection system often compare normal pattern with unusual pattern. If the new activity is very different from the expected behavior, the system may flag it as a suspicious. They can help business prevent losses and protect customer information. Anomaly detection is also important in hospital, where unusual patient results may signal a serious disease and in computer system. With strange network activity may suggest hacking. Example, a bank noticed that amount of money spent in a very large amount of money in another country. I mean, a bank may notice that a customer suddenly spent as a very large of money in another country, which could be a sign of fraud. Yeah. Next is integration with a machine learning. Machine learning models can identify patterns in large amounts of data, but hypothesis testing provides statistical support for those patterns. Combining machines learning with hypothesis testing allows an intelligent system to make more accurate and reliable decisions. This combination is especially useful in areas such as recommendation system, medical diagnosis, and fraud detection. Example, example, a recommendation system may suggest movies based on viewing history, while hypothesis testing checks whether that recommendations are truly effective. Next is conclusion and future direction. Hypothesis testing remains one of the most important tools in statistics and data analysis. It allows researchers and organizations to make decisions based on evidence rather than assumption. As our technology continues to grow, hypothesis testing will become more important in artificial intelligence, big data, and real-time system. Example, uh, business use testing to know if their advertisement or products or services are affected.
A food company said that their product can last long for 2 or more years. A customer believed that the product of food company cannot last long. By using 10 sample, we measure the average lifespan to be 1.8 years with a standard deviation of 0.15. State the null and alternative hypothesis. At a 99% confidence level, is there enough evidence to discard the null hypothesis? So, our objectives for today the is that the null hypothesis is the company said that the product can last long for 2 or more years. So, mean is greater or equal to 2. And the alternative hypothesis is m less than less than 2, because the customer said that the product is 1.8 years. So first of all, we have to draw a bell shape or normal distribution. So the confidence level is 99, so it should be 0.99. We have to shade this one, because 0.99 is a region that is not shaded, or is not shaded area. So this, or alpha, or the alpha is 0.01. So by using t-table, before I discuss this t-table is our sample is 10, and our sample mean mali. Sample mean is 1.8, and the standard deviation is 0.15, and the mean is 2. So we're not going to use z table because our sample is less than 30. Kaya lang tayo gagamit ng z table if our sample is greater than 30. So this is how to get the z table. First is we have to identify the degrees of freedom, which is the formula is df is equals to n minus 1 So our answer is 10 minus 1 is equals to 9. So in our z table, we can say that it is where is the 9, and our alpha is 0.1. So we have to find the 0.1, which is this. So 0.9 here, 2.821. So this is 0.821. By by using this formula, x min minus mean divided by s or standard deviation over square root of n. So this is so 1.8 minus 2 divided by 0.15 over square root of 10. 1.8 minus 2 is negative 0.2, and 0.15 divided by square root of 10 is 0.047434. So the final answer is, or T is negative 4.22 or 4.22. So as you can see, our answer, and so when we compare our calculated t value to our critical t value, we can say that 99% of confidence level that we cannot accept the null hypothesis that the average lifespan of the product of food company is two or more years, because our shaded area is here. So with the calculated answer, our final answer is, with 99% of confidence level, we cannot accept the null hypothesis of food of the product company of the product of food company can last long 2 or more years. And that is our final answer. Thank you.